Friction welding is the process of joining two 3D printed parts together by spinning filament in a rotary tool and harnessing the heat from the friction to weld the parts together. In this tutorial, I will cover the basic techniques and different welds you can achieve using this process. There are three main factors to master friction welding: speed, pressure, and angle of rotary tool. Make sure you're using the same filament to weld with as you did to print your parts. Here I'm using Polymax, and I've chosen blue filament to highlight the weld. Snip your filament to around 30 mm. Any longer and the rod will snap off. Try to straighten the filament as best as you can so it's spinning true. It will make it a lot easier to start the weld. Now let's look at welding techniques. Here I'm pushing the filament along the seam line. This technique is not working very well. Most of the plastic is being chewed up and spit out of the side, instead of melting and flowing into the channel. What this does demonstrate, however, is the channel that the spinning filament cuts. To get a really strong, seamless weld, the plastic needs to penetrate down through the layers and then fill this channel with molten plastic. When the filament is pulled instead of pushed, you get a much cleaner weld. The filament is still cutting a channel, but the plastic is now melting and flowing into the channel. My rotary tool spins clockwise, so I tended to get more material buildup on the right hand side of the weld due to the filament dragging the molten plastic as it solidifies. This means you may have to make another pass on the left side to create a seamless weld. To avoid making another pass, this technique of making small circles over the seam line works very well. This is the best technique for gap filling and making seamless welds. This is also a good looking weld, and the concentric circles look very similar to metal welds. This technique doesn't cut a deep channel like the pulling technique, so often you're left with a weld protruding the surface, which is perfect if you need to sand the weld down after. Now let's compare the two welding styles. Once both welds are ground back to a flat surface, we can break the welds to check the penetration depth. This first weld is the pulling technique. This is a really strong weld, and you can see the weld has penetrated down through the layers, fusing the two parts together. The small circles, on the other hand, is much weaker and has only penetrated the first 5 to 10 layers. So where the small circles is better on the surface, if you need strength, use the pulling technique. Alternatively, you can start with a pull weld and then go back over the top with a small circles technique. This way, you get a strong weld that's penetrated down through the layers, whilst keeping a nice clean profile on the surface. This last technique is the right to left weld. This type of weld is both strong and seamless. With this method, you still cut a channel for the weld to sit in, and because the plastic is dragged and deposited on the right hand side, it builds up on top of the seam line. At the right speed and pressure, this is a very effective welding method. When broken apart, you can see how the right to left weld has good penetration, and the weld also sits proud of the surface, which is ideal if you want to grind it back to a flat. You can use friction welding to also fill holes. However, it's best to use a filament with a lower printing temperature. Here I'm filling this hole, printed in polycarbonate, with polywood. It's very hard to use the same material to fill holes. To get the heat into the filament, you tend to just make the hole bigger when rubbing it against the side. By using a different filament with a lower printing temperature, you can allow the friction to build heat in the filament without creating a larger hole. That's all for the friction welding tutorial.